Hi, my name is Noah Gift, and today we're going to talk about AWS Autopilot. It's an end-to-end solution for machine learning, and it can do everything from ingesting the data. So I could take, let's say, a bunch of columns in a CSV file, drop it into an S3 bucket, point Sagemaker Autopilot at it, and then tell it to come up with a list of the best algorithms to do machine learning. It'll also be able to detect automatically the kind of machine learning problem I'm doing. So let's say I'm doing a regression problem where I want to pick a numerical value. If I'm doing a categorical classification where I want to classify, let's say, red, blue, or green, it can automatically detect that. And then later, once it's done and it comes up with its accuracy report, it'll actually give me the ability to explain the model. So it has explainability built into it. And then later, the solution itself, the prediction system, will be able to be deployed by just right-clicking on that solution. So in a way, it's very exciting because it allows you to get into discovery mode, and you can actually go through and test out a bunch of different ideas and then take those ideas and put them directly into production and then see what the results are of those experiments. So let's go ahead and get started, and we'll go from 0 to 1 with Sagemaker Autopilot. Let's get into Amazon Sagemaker and take a look at it first. So the way I usually do this is I look at my recently visited service, or I can type in Sagemaker here and it will do a keyword search and look for the appropriate service. Now, one of the things to be aware of here is once you pop into Sagemaker, it does have a call out here that says, hey, take a look at Sagemaker Studio, which is an IDE for building, training, and debugging models. And so this is really the next generation of Sagemaker. But first, let's take a look at, maybe classic Sagemaker here and see all the things that it offers. So in a nutshell, it has Studio, and this is really for preparing the data. So you can wrangle data, you can process data, you can interact with a feature store. And the feature store is where you would store pre-built features that you could use for multiple models. Really, it's preparing things so that you do less work in the future. And then Clarify is for explaining the different aspects of a machine learning model. So explainability. Now, in terms of working through things, typically what you'll do is you'll open up a notebook. Maybe you'll bring your own algorithm. You'll use autopilot, which is what we use in a second, or you use jumpstart. Training and tuning. The big thing to be aware of here is that you can use spot instances to lower your costs. You can also do automatic tuning. And so there's a bunch of different enterprise level features that are helpful. And then finally, with deployment, you can do a one-click deploy or have multiple models in endpoints and split the traffic between different endpoints and do A/B testing, create pipelines, do monitoring when it's in production. So really what Sagemaker is it's a end-to-end, fully enterprise compliant MLOps framework. And that's probably one of the best ways to explain it. Now, I'm going to click on Open Sagemaker Studio here. But one thing to be aware of is that there are different regions that you can use Sagemaker in. And you could use it in US East. You could use it in Ohio. I think Ohio is where it first was available in early release. But it's important to make sure that you're in an environment where you're going to have access to, let's say, an S3 bucket that you can use, because Sagemaker heavily uses S3 to read and write data. So I'm going to pick this US East region here, and then I'm going to click Open Sagemaker Studio. Now, what happens is once you've selected it, it's going to give me this control panel, and it will allow me to go through and open up this pre-existing studio session. So I'm going to go ahead and click that. And then what will happen is that it'll go through here and show me that, yes, this one's ready. We can actually go through and open up Studio. Okay, now that I've got Studio open, what I can do next here is give you a brief tour of the interface. Now, one of the things that I'll point out with Sagemaker Studio here is that it's important to look through these different left-hand icons. So let's go through one by one and look at them. So first, this is the existing experiments that I've done. And so you can see that a few days ago I did a autopilot prediction, and you can see that this is the components of it. Later, you can go through here and look at deployed model endpoints. So once you've done an experiment, you could go through, and in this case, if I right click on this, I could actually say deploy model. And then that, once I've deployed it, it would actually show up under model endpoint. So that it really could be the entire process to deploy a model into production. The next thing here is these tabs. So this shows all of the different open tabs here. And these could be anything from, different components of the machine learning pipeline to the model that's in production. If I want to go ahead and open up a new tab here, what I could do is I could say new, and you can see the different things that I can open up. I can open up a console, a flow pipeline, a Jupyter notebook, a terminal, text file, markdown file, model group experiment. So you can see here, it's really designed to be like a interactive development environment, but for people building machine learning models. That's really the big takeaway with Sagemaker Studio. Now, let's go ahead and look at terminal here. I think this is a good one to point out. Notice when I put terminal, now it shows up in the open tabs. And what I can do here is I could just do ps-ef grep Python. So this shows me all running processes that have the word Python in it. And we can see here that in the background here, we've actually got some Jupyter Lab components running, and also something that manages the Jupyter Lab process, which is Supervisor D. So this in itself really can get us into the weeds of what's happening in the system. If I wanted to get really into the details, I could also do a DF, which stands for basically how much usage I have on my system in terms of the file system. And you can see here that I've got an overlay file system. I've got this mount point and Etsy hosts, and we can see that I've only used 8 gigabytes of this 83 gig volume here. So there's a lot of interactive things we can do from the terminal. And in fact, I believe I can even type in IPython, and then from IPython, I could actually go through and import things like pandas, and if I wanted to, or install it if it wasn't installed, do a pip install pandas, go through and play around with it. So you can also interact from a terminal as well. One other tab that I'll really quickly show you is the notebook, and this is probably what most people would be familiar with when you're working with something like Jupyter. Is if you notice here that I can actually either open a data science Jupyter Lab environment, or I can go through and start one of these other kernels here. And you can see there's actually a lot of choices that potentially could be useful depending on what you're doing. MXNet is a smaller deep learning framework that's not as widely used, but is something that's developed in Amazon. PyTorch or TensorFlow are probably the ones most people are familiar with. But notice here that I could actually open up, let's say, a GPU optimized version of, let's say, TensorFlow 2.3, and I could start to build maybe a TensorFlow application that required a GPU very, very easily. I'm going to go ahead and pick this one though, Python 3 Data Science. Let's go ahead and use that. And then from here, again, you can see here's the notebook. I could go through here and I could rename it if I wanted to, or I could just go ahead and start writing code. So import pandas as PD, and we can see here that I can actually start to write code and experiment with this thing. Notice as well, it shows me the capabilities of the notebook. It's got 2 virtual CPUs. It's got 4 gigabytes of RAM, and it even shows me what's happening inside of this instance as well. So really a pretty interesting environment to experiment with and play with. Again, if you're a data scientist, this is maybe one of the first places you'd want to go ahead and gravitate towards. Now, the other thing that I'll point out here in this launcher is that if you wanted to experiment with different models and play around with them, you could also go through this interface, and this would actually allow you to have version models that you use for production environments. Okay, so this is really the tabs view. Now, if we go to this next icon here, what you can see here is this shows me basically the different tags that are available. And then this one shows us basically all the different capabilities of the Sagemaker Studio environment, including, any kind of tweaking I want to do to the IDE. And then in this icon here, what this does is shows me what's actually running. And you can see that in this particular environment, I've got a medium instance here that's got 2 virtual CPUs and 4 gigabytes of RAM. Now, if I wanted to do a training job, you'll see that actually other things will populate. So this is a good place to look at if you're dealing with big data. You'll see, in fact, in some cases, very, very large instances will populate, and those large instances will be something that you'll want to make sure that you have a control over. So you want to make sure that they shut down properly, and you're monitoring how much you're using of resources. And this is all something you could do from this part of the Sagemaker Studio, running terminals and kernels. And also notice here this terminal sessions. Remember, before I kind of played around with the terminal. If we go to this, what I could do is I could shut it down and get rid of it. Likewise, this untitled notebook here, if I want to go here, I could actually go here and shut that down. And now you see that that's actually shut down as well. So you can actually go through and control things from this interface. Now, the other thing is this is a Git repository interface. So you can go through here and work with, let's say, checking code in or checking code out, or modifying files from this interface. And then this is just the local file system, and it gives you access to what notebooks and what you've got on your local system. So that's the start. And the next thing that I'm going to do is I'm going to show you how you can actually use the autopilot system itself. So this is a NBA data set that I decided to download from Kaggle. There's nothing particularly that interesting about it. Just, it could be any NBA data set or any data set that I want to work with. I went through here, go ahead and download it. Once I've downloaded it, the next thing that I would do is I would go over to S3 here and put this into a bucket that I can access from the region that I'm in. So this is one of the more important things to be aware of, is looking at this region. So anything that says US East is going to be a problem, because we're in this Sagemaker environment working in Ohio, and Ohio is US East 2, and US East 1 won't work when I'm doing interactions with Sagemaker Autopilot. And so I would need to go through here and basically make sure I'm using something from US East 2. And in order to do that, one of the things that we could do is just, again, kind of scroll down here and look at the different regions and find one. Like, here we go, Sagemaker project, and I could reuse one of those buckets, or I could create a new bucket. And in this case, notice I have a lot of buckets created here, maybe too many buckets. I can actually go through here and delete this thing. Let's go ahead and delete this. This one says it's too much storage. So this will happen a lot if you're like me and you use Sagemaker a lot, is that you have to go through this dance where you have to first delete the bucket and then go through and get rid of all the different aspects of it at the same time. So I'm going to go ahead and select this one. I'm going to go ahead and say delete, and we'll go ahead and say Big Blue website, which is something I was working on earlier. We'll go ahead and delete that. Great. And now what I can do is I can say create a bucket, and I'm going to do this in US East 2 because that's where I'm working with Sagemaker. And I'll just call this NBA Sagemaker, or we'll call this NBA Sagemaker test. There we go. And I'm going to go ahead and say create bucket. and it says it doesn't want uppercase, so we'll get rid of that, and we'll do lowercase. Perfect. Okay, so now that I've got this, the next thing that I can do is I could upload the data that I had earlier into this bucket. So I can actually go through here and go to this data here and double click on it. Just make sure that everything looks good. We see here that it looks like it's reasonable data. Great. And what I can do is go to that bucket that I just created, which was NBA Sagemaker test here. And I can just basically drop this in, and now I can use it for my work. Now I'm going to go back to my SageMaker environment here. You can see these are two windows that I can close, and I'm just going to leave this Jupyter Lab window. And what I can do is I can say File, New, and that's one way to do it. Or what I can do is I can say New Launcher, and I can actually use this quick start guide. So notice it says explore one-click tutorials, build models automatically, run open source models. So in this case, because I want to do an autopilot experiment, I'm going to go ahead and click on this, and then it brings me right into the experiments tab here. Now let's go through all the options. So first thing I'm going to do is I need to call it something. So we'll call this NBA SageMaker autopilot. There we go. And then for a project, we could call it something, or I could just leave it alone. And then it's going to say connect your data. Do I want to enter into an S3 bucket location? Sure, let's go ahead and do that. And then from here, all I need to do is either find the bucket or select it. In this case, I think I can go down to this NBA SageMaker test. Now notice, again, the ones that are US East 1 or West aren't highlighted. This one is highlighted because it's in the right region. And then it's going to ask me for the name of the data set. It knows inside of there that here's a CSV file. And now what I'm going to do is I'm going to select the target. And so what I'll need to do is just double click here real quick and look at this data set. And you can see here, let's just find a target that seems like a fun one to pick. We could pick, what someone's age is. That could be kind of an interesting one to pick. Could we predict someone's age based on their stats? I think that probably could be the case that we could do that. Also, what is the player's height? What's their weight? I think all of these are fair game. Let's go ahead and see if we can pick the age, though. That seems like kind of a fun one. So I'm going to go through here and say target, and we'll just pick age. And then for the output, where do we want to put the result? So we can just put it in the same location. That's fine. I'm going to go through here and say SageMaker test. And then here is where we can actually get into some of the automation aspects. So do we want this thing to automatically figure out the type, or do we want to tell it what it is? Binary classification, regression, multi-class classification. Really, in this case, we probably could just ask it to automatically figure out that it's a regression problem because it's a numerical value, and we want to pick what it's not a category. It's a number that will go up or down. And so I'm going to go ahead and pick it as a regression problem, just so that I can have a little bit more fun with it. But auto would work as well. And then I can pick what kind of metric if I wanted to. And then do we want to run through the complete experiment? And notice as well, there's advanced settings here if I want to go in and pick different roles or encryption keys or how many trials we want to do. But I'm going to go ahead and say create experiment. There we go. Now, once you go through and you create the experiment, it could take really anywhere from 10 minutes to several hours. It really depends on what kind of a problem you're solving, how big the data set is. But the series of steps that it goes through is, first, it goes through pre-processing. Second, it goes through candidate definitions generated. Then it goes through the feature engineering process. And then finally, it'll go through model tuning. So right now, it's in the pre-processing step. So what we can do is let's go again to this interface here where it shows you the running terminals and the current and the kernels, and notice that what's going to happen is that in a little bit it's going to pop up here more running instances, because it's going to go through and manipulate that data. And so again, it's a full end-to-end automated system that allows us to go through and tell SageMaker to do all the heavy lifting for us, including grabbing the data out of S3. And if the case was that it was really large data, it could figure out how to do that automatically for us. So we're going to go ahead and let this thing work for a second and then come back and see what it's doing. All right, let's take a look at what's happening here. If we again go back to this experiment, we can see that the candidate definitions has been generated. So we can go through and click on this, open candidates generation notebook. And what will happen is that it will give me a notebook that tells me a little bit more about what's happening in the project. It says this notebook was automatically generated by the AutoML job NBA SageMaker Autopilot. This notebook allows you to customize the candidate definitions and execute the SageMaker Autopilot workflow. Notice that it's able to infer how many columns there were, and also it's able to pick that age is the target column. It also knows that it was a regression problem, and then it tells us as well what kind of a metric we're going to use to develop the accuracy. And in this case, it says the MSE metric stands for mean square error, and it minimizes the square distance between the model's prediction and true answer. And so what's nice about this is that later I can completely reproduce this problem, because it goes through and it gives me the artifacts of how it was able to generate this. And then later I could prepare the data and do exactly what this was done before. And so this is one of the nice things about it, is it does a lot of the automation for you, so you can build a reproducible AutoML system. Now, if we go back here, this will take a little bit of time, the next step here, which is feature engineering, and then we'll go ahead and let this run and then see what it comes up with in terms of its feature engineering problems. Okay, so we have feature engineering is complete here. And one of the things that we can take a look at now is that there's two different tabs. So we already looked at the open candidate generation notebook, but we also can explore the data, right? We can do exploratory data analysis while this is finishing up the model tuning. Always a good idea to get a better understanding of your data. So let's go ahead and select this open data exploration. And notice here that it has more information. It says there are 11,145 rows. Again, it tells us the descriptive statistics. And then it said for regression, it found that the ranges were 18. So we know it's the minimum age of the NBA is 18, and 44. It would be pretty difficult to be a good player in the NBA in your 40s. And so really 44 is about the limit of the age that you can play professionally in the NBA and be competitive. So if we scroll down here, we can actually see a data set sample. This is really nice because it goes through and it tells us all the different columns. It has them nicely formatted and gives us a view of it. We also can look at the analysis. So it also does basically data science for us. So it goes through here and tells us things like, okay, were there any empty values? And said one of the 22 columns contains some missing values, college. And so it found that 15% of the values were missing. And then in terms of counts, it can give us statistics. And then we noticed right here that the number of unique entries, it gives us basically all of the different unique values here, which is pretty neat. So we see that there's only 8 rounds in the NBA draft. So there's only going to be 8 different categories. There's only 24 seasons listed. In terms of the age, there's only 27 unique values. Height, same thing, there's only 30. And in terms of, let's say the player names, well, we would assume that there would be a lot of common NBA names here. And so this also gives us a really good view of the data set and tells us the different things that are useful. And then in terms of descriptive statistics, again, this is a really critical part of data science, knowing the data sets. We can look at the median values. I think median is a good place to start with. Most people in the NBA get about 3 rebounds a game, but there are some that we're getting around 16 rebounds a game, which is on average, which is really truly incredible. In terms of points here, we can see the average NBA player scores about 6.5 points, but there are some players that were averaging 36 points a game for a season, which is truly incredible. Same, we can see median age in the NBA is 27. So in a nutshell here, you can see how powerful this is. It really is like a data scientist in a box. This is the kind of work that a data scientist would do. They would put some data somewhere, run an analysis, and then give us a report. But we just ran a piece of code here, just clicked a button, and then it gave us this whole exploration for us. Now I can go through here and click Import Notebook. And then what's great about it is that I can then go dig into it a little bit more, which is pretty cool because this allows me to, maybe later do some other things with this particular notebook, maybe generate a report or share it with other people in my organization. And in a way, it's actually a great way to look really good because this report was automatically generated for us. Now, one other thing I'll take a look at here as well as this is going through its model tuning is that notice that there's trials tab here and there's jobs profile tab. And in particular, the jobs profile, you can see that this job was created roughly 20 minutes ago. It was last updated, 3 seconds ago. It periodically refreshes. It tells us the progress, right? It says in progress here for the status. It tells us the type. It gives us secondary status. It says basically what is happening in the background here, who's doing what. And then later we could actually go through here as well and look at the input data. We could look at where it's actually pulling that from. We know that that's the bucket we created. We also can look at the resolved attributes. So what is the problem type, regression, what's the objective, mean squared error, what is the maximum runtime per training job, and also look at the configuration data. We didn't put any configuration data initially, but I could look at that. And then summary, once it's done, what it'll do is it will give us this details here about what are the best candidates, what are the pieces of information in terms of how to use that model and put it into production. This is all stuff that's generated in this jobs profile. So it's a neat thing to look at while you're waiting for the model to run. All right, it looks like we have some trials that are complete here now. And in particular, we can see that what's happening is that it's going through and experimenting with a bunch of different results here, trying out different ideas of models that it can pick. And if we filter by objective mean squared error, you can see there's a wide range of values here where we've got 2, which is pretty low mean squared error, all the way up to 700. And notice here it found the best model that it's going to recommend here. And what we could do is if we wanted to, we could just go right to deploy model. So let's go ahead and have some fun. Let's click that deploy model and see what happens here is once we go to real-time deployment setup, notice that what'll happen is we would have to call it some kind of a name. So we go ahead and say, hello ML, and then it will give us a default instance type and instance count. We can even capture the data of the prediction requests and the prediction responses if we wanted to. And then as well, we could do batch transformation. So let's go ahead and do the deploy model here. And notice that it will give us the ability to do monitoring, right? So we can monitor the model quality. We can also look at the explainability, bias, AWS settings here. These are all things that you can do once you've deployed your particular model. So let's go ahead and let that thing sit there for a little bit and do its work. And I'm going to go back here and I'm going to go again to this model and I'm going to right click on it and notice that it has a bunch of different options here. So we did deploy already, but open in trials component list, you can see here, this shows all of the different trials that were performed and gives us that information. That's one thing we can open up. Another thing we can do is open up the details. And so the details is neat because what it does is it shows us all the different charts of what happened when it was building the model, and you could go through here and look at additional information. And you also can look at the metrics. So in this case, we can see what the final value was, and in this particular objective metric here, we can see that the final value was 2.21 for mean squared error. We can look at the parameters, so we can see the kind of tuning that was done. If I wanted to later reproduce this, I can look at the artifacts. So we see that in fact, the model itself was created right here. So I could then take that model if I wanted to and even deploy it somewhere outside of AWS. We can look at the settings here. Again, this tells us the kind of algorithm that was used, what the instance was, what kind of protocol was used to interact with the model. Basically, every kind of a button that you would want to select has got it. Also, you can go through here and look at explainability as well, is another option. And so in order to do that, they give you a set of instructions here on how to set up model explainability. You can do a bias report or trial mappings as well. So there are a lot of different options here beyond just going through and deploying the model into production. It will go through and show you, again, just one click, right click, and deploy the model into production, which is one of the things we did. So in a nutshell, this SageMaker Autopilot really does solve some significant problems for deploying production code MLOps in an organization. And I would recommend using it if you have SageMaker in your organization and you have the ability to put things in S3. Really, there's no reason to not at least experiment and see how many things you can automate. And I think SageMaker Autopilot is going to be one of the go-to solutions for organizations that want to implement MLOps quickly. All right, now that we've gone out of the SageMaker interface here, let's go ahead and take a look at the training location here, and let's double check, do we have any more training jobs? And notice, in fact, that there were a bunch of them in progress. So you can see this was complete, this one's in progress, right? So that's very important to know that that's happening in the background. And I could, if I wanted to, I could look for, let's say, status and look for, in progress. This is probably a good idea if you're doing a lot of these in your organization, and look at all in progress training jobs and just see what's going on. Are they getting stuck, or are they running for a long time? And this is one of the advantages of using a tool like SageMaker, is it gives you this search capability. Now, the other thing is, let's look at hyperparameter tuning. Look, this one's actually running as well. So you can see that it's actually going through here and giving us some information about what kind of hyperparameter tuning it's doing. And we can even look through here and see what was the best training job and look at all the different hyperparameters for that regression model. And this really is a powerful service because we have historical data now, and I could go back and look at the different hyperparameters and play around with it so I can interact with this automation and use my human expertise to make it better. Now, we can kind of let these things run here, but the other thing I wanted to highlight was, because I told it to deploy to production, we can look at this inference here and we can go to endpoints, and notice what's happening is that it's going through and it's creating now a production endpoint. If I click on this endpoint, what's going to happen is that it's going to give us this URL here that I can invoke and actually create predictions, and I can learn more about the API here. And so what we can do is we can actually post things according to these parameters, and this gives you the HTTP headers that you'll need to use. And then also what was the endpoint that we would want to use, and it gives us all of the information I would need to do to make a request to that endpoint, so I could give that to other people in my organization, and they could immediately start using this endpoint. So the other thing to point out is that, again, with this one-click deploy here, we can go through and monitor that endpoints, look at the CPU utilization, memory, go ahead and look at all these different things, the configuration. And if I wanted to as well, I could deploy multiple endpoints and then update them into some kind of a auto scaling setup or even A/B testing. Really, this is one of the great things about Sagemaker Studio, is just how quickly we're able to go to production here. And look, here we go. It's now in service, and I can again go down to this endpoint, take a look at it, and run it. It tells us as well the model, and so this model, it actually puts it into S3 for us, and I again could download this and put it somewhere else. It even tells us what training job created it. So the reproducibility, I think, is really a strong aspect of why you do this. Now, notice I didn't set up data capture, but we could have done that as well. And then finally, again, if I go through here and I want to, add multiple endpoints and try some A/B testing, I could go through here and change that with a variance. What I'm going to do, though, because I don't want to be charged for this, is I'm going to select this. I'm going to go through here and I'm going to say delete, and then I'm going to clean up the final bit of work here. So that's also a very important thing to do, is if you are experimenting with endpoints, make sure you do delete them manually. Unlike the training jobs, which will automatically go through and finish off, the endpoints will not, and you'll be charged for those endpoints unless you really did want to go through and deploy things into production. So in a nutshell, this SageMaker Studio is a great resource for doing full end-to-end MLOps for your organization, including deploying it to production.